Good afternoon, everybody at Web Summit. Boy, it's just a huge pleasure to be here. I realize I'm the last presentation before, as Patty said just a second ago, you get to go sample some of Portugal's finest. So today, I've got a couple of demos here. Everything is going to be live. We always do everything live. But I want you to think about that we're really talking about two topics today. And those two topics are data and artificial intelligence. And data being the primary first one we're going to spend some time talking about. At Intel, we believe that data is becoming one of the most valuable commodities on the planet, and that every company needs to and should have a strategy around data. In fact, we've coined the phrase that data is truly the new oil. If you think about how oil really transformed the 20th century, data is going to transform the future. And artificial intelligence just is driven by the fuel of data. I wanted to take a second, though, because we've gone through these transformations before. And every time we go through one of these transformations, we think about what's going to change, what's going to happen to what we know. So I'd like to take a look, to start today off with, a little bit of how far technology has come and the impact it's truly had on our lives.
Now I heard you go too fast and you'll melt.
Electricity. I'm not putting lightning in my walls.
No, I'll live flying to the birds.
You know, it mutates all the nutrients in your food.
They have these little soaps there that I can't find anywhere else. Oh, my hands smell amazing.
Do you really need to talk to people all the time?
Soon, artificial intelligence will be able to flag a health issue before you even come for a checkup.
Yeah, I don't need a machine to tell me how to live. Ooh, I'm gonna be late for a meeting.
Intel is powering artificial intelligence that can help doctors save lives. Don't worry, we'll help you get there.
So that was... That was just kind of a fun way to take a look at every time these innovations have come. People have looked at them with confusion or skepticism or risk. But every time they've become an integral part of our lives, and they've always expanded our lives and made the world better. And I think that's what we want to really talk about today. The importance of data, how it's fueling many, many new opportunities, and how artificial intelligence is just one of those, and how artificial intelligence is really more than just one thing. And I think people think about it in one way, but it's much bigger than that. So we're gonna talk about 4 topics today. The first is reimagining data. A lot of people think that the world's already creating a lot of data, or I've even had people tell me, we're creating about as much data as the world's ever going to create. And one of the things we're going to show you is that we've just touched the beginning of the data revolution. And that the data of today is created mostly by people, and that the data of the future is created by machines. And they create massive amounts of data. The next thing we're going to talk about is that artificial intelligence is not just something that sits in big data centers and is applied down to your device, but it needs to be applicable out at the edge. Things need to become smarter out at the edge where they're interacting with us. I want to show you then how data can be used to make an immersive media experience, how it's going to transform how you watch one of the most fun things we do, probably most of us in this room, every day, every week. And then lastly is artificial intelligence for good. that we believe there's so much good that's possible. We're going to show you just one example of how Intel is working with some partners to truly bring opportunity and innovation to something that is a problem for society. So let's get right into it, and let's start with data. By 2020, the estimate is that the average person will generate about 1.5 gigabytes of data per day. And that may seem like a lot. You generate about 600 megabytes today. So we're going up by almost roughly 2.5 times in the next 3 to 4 years. But you, as a user, which is mostly where the data comes from today, will pale in comparison to the machines. Autonomous vehicles, which we've all been talking about here, can generate up to 4 terabytes of data a day. And that's just assuming they're driving a couple of hours each day. A connected airplane, with all the sensors that are on the airplane, will generate 5 terabytes of data. A smart factory, a petabyte of data. And just video moving over the internet will do about 750 petabytes a day as our video consumption continues to grow at an amazing rate. And freeing up our time with things like autonomous vehicles is just going to increase that data rate and that video usage. So we're just beginning to touch the edge of data in the world. And it's going to be driven more and more by the machines that we all interact with. Now, artificial intelligence is the next major technology that's going to provide value out of that data. Now, what you need to understand is like any technology, it's not one thing. Artificial intelligence is not just simply one event, one program, one type. That you need to have solutions that can go from the very edge, small devices that are on your body, in your home, that you carry with you, that are flying around you, to large data centers. And the technology that you use for these varies. So we're going to walk through some of those today, and we're going to walk through how and why you're going to want to have that technology, that artificial intelligence, in all of these capabilities. And we believe that artificial intelligence, more and more, as it becomes closer and closer to you and gets out at that edge, will become more something you rely on and more instrumental and play a bigger and bigger part of your life. Not limiting your life, not taking away opportunity, but enhancing all of those opportunities. So let's start with how do we go about thinking about bringing artificial intelligence to the edge? So edge devices like phones and security cameras and autonomous vehicles like drones, they can all benefit from fast, low-power artificial intelligence. So I'm going to show you a place today where we've made huge advances in bringing artificial intelligence, convenient, low-power, out to edge devices. One of the devices that we've been working on and is now available is a Movidius neural compute stick. We've been using this stick to bring AI to drones, like you see in the picture above. With the Movidius compute stick, we're making artificial intelligence out at the edge possible. So I want to show you another quick video of how this is being applied in those drones out at the edge. And it's just going to be the start of it, and then we'll go into a demo. So let's hear from the experts about how critical drones and artificial intelligence can be to real-time everyday life.
Australia has a very long coastline, and that presents us with some unique challenges. Drones provide us with a great opportunity to get a life-saving service outside of where we traditionally have those services now. In 2015, we used the first drone to fly along a beach and look for people in trouble and to save lives. We use the drones 3 ways. The first is for surveillance. So we're able to get vision and understand situations, understand when people might be getting into trouble. We have warning devices, loudspeakers fitted to the drones so that we can actually warn people that they are about to get into trouble or what to do if they are in trouble. And the third thing is that we can intervene and deploy an automatically inflatable rescue device from the drone which can support up to 4 people. And it keeps them afloat in the surf, in the water, until they can be rescued. Earlier this year on the Central Coast, a sandbank collapsed and 12 people were washed into deep water. A life-saving drone was sent to the area and quickly located exactly where they were. Lifesavers responded to the area very quickly and all 12 people were saved.
If we could get that longer flying time, it would be really helpful for our job as lifeguards, as well as being able to fly in poor weather such as high winds and rain, because that's when we're going to need that aerial perspective. And if the integration of the life-saving technology in the drones could be improved, such as the shark spotter, that would be really helpful in our jobs as well.
So if we can use artificial intelligence to help us detect people and respond to situations, then that is going to be a wonderful opportunity to save lives. Little Ripper Lifesaver have very advanced life-saving drones. Intel has very advanced artificial intelligence. Imagine a world if we combine those two together. What a great opportunity to save life anywhere in the world.
So as you heard, the request was put artificial intelligence together with those drones and imagine the number of lives we could save. So to give us a little bit of a demo of just that, I brought Diana on stage and she's going to show us just what an intelligent Little Ripper can do. Hi Diana, can you show us what you got?
Sure, Brian. So as you saw in the video, Little Ripper Lifesaver has been doing a great job making Australia's coastline safer. And they now have an artificial intelligence-based solution to be even more effective in that mission. But it's a cloud-based artificial intelligence solution. So that means if I'm out there in the ocean and I need help, my potential rescue drone is going to need to take video of my surroundings, send that video to the cloud for AI analysis, and then wait before deciding if I need to be rescued or not.
And if there's a big shark after me, I want that response quick.
I may not have that much time. And what if the drone loses connectivity in the meantime?
Bad for us.
Bad for me, anyway. So a possible solution is to take the Movidius neural compute stick, put that on the drone. You can see it's just a USB stick, so it's small, it's light, doesn't need much power. And once you have this on board the drone, you can do your AI processing right on board, no need for cloud connectivity. Would you like to see a quick proof of concept?
I'd love to see it. Let's see it at work.
All right, so here I am. I'm in the ocean again. And you can see there's a shark in my vicinity. I have my demo drone over here. Let me just give you a look at that. It's got the Movidius stick on it. Let's take a look at my little demo drone. And I'm going to fly this little demo drone over the ocean. And when the demo drone is able to hopefully detect that there's, let's see here, demo drone, come on. And the demo drone here will show that there's a shark detected. And now that it's seen that the shark is being detected, I hope that means that there's going to be a rescue drone in my near future, maybe with some shark repellent. Oh, I think I hear it. Oh, but I also hear the shark. What's going to get here first? Come on, drone. Shark repellent. All right. Yes! And I'm saved.
That's great. Thanks for that fun demo, Diana. That's exactly what we want, though. That was all done live with edge compute, no going back to the cloud.
Exactly.
Just right on the drone itself.
Right. Great example of the power of AI for edge compute.
Thank you. So we had a little fun with that, but the idea here is to really think about artificial intelligence differently. That you don't have to have that drone with the connectivity back to a large data center and hope the connectivity's there. That using the Movidius compute stick truly doing neural processing on the edge, you're able to do identification real time and take actions. And that's going to be where the future is. And you can imagine with a device like that, where it's simply a USB connection, fairly simple to program, the capabilities that you can put into devices, from cameras to drones to robotics. Almost anything can have a level of artificial intelligence that lets it make good decisions, sometimes life-saving decisions out at the edge. So we've talked about kind of the lower power, highly mobile devices out at the edge. I'd like to shift now to an edge device that will become more prevalent over the next several years, and that's autonomous vehicles. Autonomous driving is one of the areas where we see incredible opportunity. And there's been incredible progress in artificial intelligence over the last few years in this space. And what's driving all of this is data. Data is what's driving that car. And that data is then processed through artificial intelligence, but truly you can think of it's data. And the amount of data that's being collected, both visually through those cameras and LiDARs, and then transferred into visual data and mapping data, is in a tremendous amount. We talked about 4 terabytes in just a few hours of driving. In August of this year, Intel acquired Mobileye, which is a global industry leader in vision-based advanced driver assistance systems, or what's commonly called ADAS. And you see Mobileye technology in many, many of the advanced driving cars that are out there on the roads today. But we're collaborating with many partners right now, and we're building a system that also collects data to allow real-time mapping, so that as the cars are driving along and they notice accidents, they notice construction, they're feeding that data back and allowing the maps to be updated real-time in an efficient, cost-effective way, thus allowing the cars that are behind to have a much more intelligent capability. They know there's an accident coming up, and they can steer around it. They can reroute. They know there's construction and what the path around that construction is. So I'd like to first take a look at what that action looks like on the road. And we've been testing our mapping technology on the roads for quite a while now. And I want to walk you through and show you how it identifies all the objects around the vehicle and maps the space. So what you see here on the screen is the Mobileye system. And you can see the green is the path that the car wants to travel. And you can see it outline the people, the signs. See that sign up on the right there? And all of the cars. It also identifies, you can see the green light up above. And so it sees the street lights. And this is what the car is seeing as it's driving along. But it's collecting all this data. So you can imagine if it comes to a construction or an accident, it's able to gather this data real time, map it out, send that data up in a very cost-effective way, distribute it to the rest of the maps, and send that back out to all the cars that are coming behind it. And we believe that this is one of the critical aspects that's required to make autonomous cars really usable on the roads. That they have to be flexible, and they have to have the ability to get that mapping in almost a real-time way. So if you think about autonomous vehicles, there are 5 levels. You'll often hear this: level 1, level 3, level 4, level 5. And it's really pretty simple. Level 3 is what people will call conditional automation. Car can park itself. Maybe it can go from on-ramp to off-ramp on the highway, hands-free. You're starting to see cars emerge with level 3 now. Level 4 is high automation. That's when car can drive pretty much on its own. But in complex situations, maybe roundabouts, it's not quite ready to do that. And then level 5 is the fully autonomous. And this is where everybody's headed. And that's where you don't need a steering wheel, you don't necessarily need a driver, and you're really, truly, from start to finish, driving in an autonomous way. And we said that we'd build 100 level 4 systems, or highly autonomous systems, over this next year. And those systems are going to be distributed throughout the world, driving. Now I'd like to introduce the data collection vehicle we're using to model for our 100-car fleet and bring that on stage. So as I mentioned, you're going to see these cars all over the world on the streets. You can see them now, and in fact, I drove one of these for a few weeks, just mapping my route from home to work each day, so that towards the beginning of next year, when I step into an autonomous car, my route is already pre-mapped and understood. Each car has a series of sensors, and that's really the important part of these cars, is that it's a fleet of sensors. And where one sensor is strong and weak in other areas, maybe it can't see in bright light, but it sees great through clouds and rains, the other sensor has that strength. And the combination of all of these makes it so it can see in almost any condition, any situation. So we have LiDARs, cameras, radar. As you come along the side, you see even more cameras. You have multiple GPSs because you want to know precision location and differential GPS. And then again in the back, because you want to make sure what's behind you as well, a set of cameras and a set of LiDAR systems that are looking back as well, and sensors like radar and sonar. These sensors will seamlessly integrate into the vehicle's design, as you'll see in the fleet of the first 100 cars. So as the car drives off now, we think about this in a very unique way. Today, there's over 30 million vehicles on the road. And those 30 million vehicles have at least one Mobileye camera system gathering data already. We think of ourselves as the eyes and the brains in nearly every autonomous test vehicle on the road today. So when Patty talked about Intel being in the computing devices from the beginning of computing, and it now extending well beyond the PC, these autonomous vehicles are just one example of that. The drones were another example of that. These test vehicles will be on the roads globally over the next year, so we can continue our mission to make driving safer. All of this really pushing for autonomous fleets by our OEM partners as we move through the rest of this decade. Now, while we see the possibilities in autonomous driving, what we really think about is the safety of the vehicle and how that can really change the safety perspective of driving in general. Globally, over 1 million people a year die from vehicle crashes. And most of those are due to human error. So as we talk about artificial intelligence and autonomy and what it can bring to society, this is a great example of how it can really bring benefit. So we're working on safety models to ensure that self-driving vehicles operate in a safe and responsible manner. And the benefits go well beyond safety. As we think about autonomous vehicles, we need to think about redesigning our cities. We need to think about all of the parking, the congestion. And if that starts to go away, even as just a small percentage, say 20 or 25% of the cars become autonomous, we'll start to feel the difference in our cities. As that number grows to 50% or higher, we need to think about reimagining our cities. What do we do with the parking space? How do we really use that for more of what humans want and enjoy? And all of that is closer than any of us think today. This data revolution that's happening at the edge, we think is one of the most critical ones that's going to occur over the next decade. And these technologies that we're showing you here are going to power and fuel. But all of this is driven by data. I want to move into the next section very quickly, and that's immersive media. Now, if we think about it, sports has been one of the most viewed, most watched media events throughout our lifetime. And over the last 30 years, technology has profoundly reshaped that. We talk about now how we can take our sports with us anywhere. We can watch the highlights from the night before. The content is there and available to us, but it's as it's fed to us, what people allow, what we're given. But in our minds, that's not enough. It needs to be programmed and produced by you, and it needs to feel live. And so that's what we're doing. I want to talk to you about the first of our sports partnerships. And that first partnership is with an organization called La Liga. So Intel's partnering with one of the most innovative sports organizations and leagues around. It's the first European football league to provide fans with an immersive experience. It's using Intel's 3D technology. What we do is we put 36 5K high-definition cameras around the stadium, and that allows us to create cutting-edge replays. And first, we're offering broadcasters the abilities, and eventually we'll offer viewers the ability to produce these amazing clips that give you an advantage view from any perspective. And these 2D clips are produced by bringing every camera, the 36 cameras together, producing them through a large server, and making a digital image of the complete field. Just one 60-second replay generates over 1 terabyte of data. Once we have it digitized like that, we can watch it from any position. So let's take a look at some of the action from some of the La Liga football games and the 3D technology.
Que se está jugando esta noche en Barcelona. Formidable la cooperación entre la Liga e Intel durante la temporada 2016-2017. Espectacular producción de MediaPro. Brutal la jugada de Cristiano Ronaldo. Formidable la temporada de fútbol este año en la Liga. Increíble la imagen de Intel 360. Segundo clásico de la temporada se disputa aquí, en Madrid. Espectacular gol número 500 de Leo Messi con el Fútbol Club Barcelona.
Those are some incredible clips but they're just the beginning. You can see that each point there we were able to stop and turn 360 and see it from any angle. And that's the beginning. We want to show you now how we've continued to innovate with this technology. We've partnered with the National Football League, that's the US football, and we're doing that same 3D technology, the same 30 to 40 cameras in the stadium, and we're expanding the capability. And we're taking you right down on the field. So I'd like to show you another video that gives you that perspective. And what you see here is there's no camera in the player. We take a digital image and we go right down. Think of this as we're simulating real time what the player saw. Imagine any sporting event and you're able to go inside their helmet, their eyes, and see exactly what they saw. No more questioning, how did they make that pass? How did they miss that goal? Whatever the sport is, you can now go in and see what they saw. This is going to transform how you view sports, how you think about sports. I'm always amazed at this. This is only one aspect of how we are finding new ways to immerse ourselves in the world of sports. What we're also doing is we're working on what I'll call more traditional VR. And this is what we call Intel's True VR. And this technology is giving you, the fans, the flexibility to be at home, but to feel like you're sitting right in that stadium. And we can do this much simpler, much lower cost, and much more expansive. We've done almost every type of sport you can imagine, from golf and skiing to basketball, football, soccer. We've done all of them. If you want to be at courtside to see a bird's eye view, the choice is yours with the Intel True VR. To show us how this technology works, we've invited Chuck here to give us a real demo of how True VR works in person. Hey, Chuck.
Hey, BK, how's it going?
Good. So can you show us a little bit about True VR?
Absolutely. So like you were saying, True VR is very immersive. It lets us go to all these games and view things in new and unique ways. Now, I'd like to take you to a real game today, but we don't have anything streaming. Times are a little bit off. So I'm going to take you to one of my favorite experiences of this last year, the NCAA basketball tournament. Now, for those of you who have never seen that, it's the premier basketball college championship in the US. It takes the top 64 teams and puts them in a single elimination tournament. The fans go wild, there's huge upsets. In fact, it's earned the name March Madness. So let me take you to that championship game from earlier this year. So I can just hop into the game here. Now you can see I am courtside. I mean, no one has a better view except for maybe this referee standing here, but I've got the entire stadium I can look at, but I'm not limited to just that view. I can click to any view I want, watch the game from multiple positions, and check this shot out. Boom, nothing but net, right? That's a great immersive experience, and I can have any seat I want anywhere in the stadium.
Yeah, and I have to tell you, I watched March Madness. It was in Las Vegas. I was sitting on my couch in the Bay Area, and I felt like I was there this year. It was an amazing experience. So you've got all this, and you've got it all digitized now, so it seems like it's a perfect place to apply AI, too. So can you show us how we've thought about that, too?
I can. So I'm going to go ahead and launch the AI in this system over here.
Now, like all our demos are live.
AI solves so many problems, and if you're a sports fanatic like me, the biggest problem I have is I can't watch all the games I want. I pick my favorite game, and then I hope I can catch the replays at the end of the night. So let me show you what happens when you take AI and put it in True VR. So you can see I have that same great view I had before. I'm courtside watching these great basketball games, but it's a little bit different. I want you to look across the top here. I've got these little green circles, and one of them is red. Now what's happened is I've got AI bots with the help of Sports Radar, and Are You Watching This, that are monitoring all the other games that are going on. And when something exciting happens that's of interest to me, it gives me a red icon. I can look at it, and it tells me Oregon closes the gap in the final minutes of their game. Now, Oregon, that's my home college, so I want to actually check that out. Oh, yep, shot's going up. Boom. Score, three-pointer, tying the game. So I would have missed that without AI.
That's a great example of how artificial intelligence combined with all this data can really give you a different viewing experience and allow you to see everything. You can have every game real time.
Nope, it's a great experience and we love AI.
Thanks a lot for showing us that, Chuck.
Thanks, PK.
Those systems are here now, and in fact, everything we've shown you so far is available now for use. What I want to talk about now is the next sport we're going to apply Intel True VR. The next obvious sport, which is what we just watched, is the NBA. And we're here to announce today that we're in an incredible partnership with NBA and TNT Turner that's going to bring NBA to VR using the Intel True VR platform. It'll be starting with the All-Star game in February and going from then on with every Turner broadcast of the NBA that occurs the rest of the season. And it'll allow you to watch the game in Intel True VR using the Gear Oculus headset from anywhere in the world. And as Chuck showed you, you'll be able to choose your position, choose your seat. You produce the viewing experience. So we believe that the future is immersive, that everything you watch is going to shift and change. And as you watch this space, as we go through the remainder of this year, you're going to see a lot of other announcements by Intel around immersive video, around immersive experiences. And the combination of this highly computing data and artificial intelligence. The computing power behind 3D and Intel VR is an amazing amount of computing, and one that I believe Intel is uniquely qualified to solve. So now I'd like to take a look at our last little example today, and that's really AI for good. And we wanted to end today with a real good example of how artificial intelligence can really change and improve society. And I felt like there was no better example than the challenge of finding missing children. So Intel has partnered with Thorn and the National Center for Missing and Exploited Children to help support this important cause.
There are no countries, no boundaries, no winners. There's no waiting for someone else to do it. No eyes shut, no standing by until tomorrow. No good enough. There are nearly 2 million children exploited in the global sex trade. 63% of child sex trafficking victims in the US are sold online. And until both those numbers are zero, we will not rest. None of us should. There are no excuses, no other options, no time for no. Together we can use technology, ingenuity, and human know-how to end child sex trafficking.
So as you just heard, AI has the power to help everyone, especially those who can't help themselves. And I wanted to show you an example of how this really works in person. And so we brought Chuck on again to give us a real live example of just how hard this problem can be, but how easily it can be solved with artificial intelligence. So Chuck, why don't you show us what you got here?
So BK, as you saw in that video, there's nearly 2 million children exploited in a global sex trade. Now what happens, many of those children will find their faces plastered on either print or online sex ads. Now the first thing the authorities will do when they come across a missing child case is they'll take a picture of that child and they'll try and match it to one of those millions of online ads and printed ads. It's extremely tough to do, but if they can find a match, they can gather the clues that can lead to the recovery of that child. So I wanted to give you guys an example of what that's like, because it's a very heavy, manually intensive task to try and match those pictures up. So up on the screen, you can see I've got a child on the left-hand side, and on the right, I have 12 other children. Now, if you look at those, you should be able to find a match between the child on the left and the child on the right. And it's fairly simple, right? There's only 12 of them. Do you see it, BK?
I got it.
Right? So with 12 children, it's pretty simple. But let's make it a little bit harder. Now let's do another child on the left. Instead of 12 children, I want you to do it with 144 children. Now go ahead and look. It's going to take a little bit longer, but it gets extremely difficult.
I'm still looking.
Right?
I've done this.
Now imagine it's not hundreds or thousands or even tens of thousands, but hundreds of thousands and millions of pictures that you have to try and find a match in. It's extremely difficult. Then add to the fact that those pictures in those sex ads, they've changed their hairstyle, hair color, skin tone. And probably the most difficult problem of all, those children have aged.
Right.
So you've taken an extremely difficult problem and made it even harder. So we're going to show you how AI can fix that. We've got an application on here that was developed by Thorne called Child Finder. Now what Child Finder does is we can load a picture into it, which is this top picture here, and we can have it then analyze that picture and try and find a match across those thousands and millions of pictures that are on those sex ads. Now, all these children that are in here are part of the National Missing Children and Exploited Database. And you can see there's literally thousands of them in here. But with a simple touch of a button, it goes through and it sorts all those pictures and ranks them in the likeliness of the child we're looking for. And in this case, we know that that #1 rank is the same child as the child on the top. So this AI works, and it helps us bring those children home safely.
I mean, it's an amazing example because the picture at the top, they've changed the haircut, but it's the same child. And it's just a great example. Thanks for showing us today, Chuck.
Thanks, BK.
Thank you. So when we talk about artificial intelligence, when we talk about what the potential is, imagine a world where we can eliminate things like missing children. We can find them on a variety of methods and tools. This is a world that we envision and one that we're working on right now with our partners. To bring the children home and to bring them home safely. So as you've seen here today, there's a broad spectrum of ways that data and AI can change our lives for the better. And that's what we really need to focus on, and that's what we need to think about. From edge devices that are mobile and becoming more and more intelligent, to large data center applications like immersive video. We have a saying at Intel that we not only see the future, we build it. And hopefully tonight, I've shown you a little bit of that. Thank you for giving me this talk tonight, and thank you very much. Have a great event.